my name is Cindy Williams, and today we will be talking about inverse trigonometric functions. So similar to quadratic functions and exponential functions, trigonometric functions also have inverse.
At first glance, this is sine of x, and at first glance you wouldn't be able to tell that this trig function had an inverse because it does not pass the horizontal line test, meaning that for one specific input there are several outputs of the same value, which we cannot have. For this reason, the domain of all trigonometric functions must be restricted in order for it to actually have a inverse. So for specifically sine of x, the inverse would have a domain of negative pi over 2 to pi over 2. So this is negative pi over 2 to pi over 2. And this would be the restricted sine graph, or the inverse, which is called arcsine. As you can see with cosine, it has similar properties to sine, considering the fact that it starts at 1, but that doesn't matter right now. This still does not pass the horizontal line test, which means that the domain must be restricted. For cosine, the domain will be restricted from 0 to pi. So this would represent the arc cosine graph. Tangent has a really funny case because if you look at one tangent graph individually, it actually fits the horizontal line test and it will actually be a perfect trig function. However, because of these several graphs, the infinite numbers of graphs, it does not pass the horizontal line test. Therefore, it must be restricted. So when you look at arctangent graph, you can see the domain is all real numbers, which is not necessarily a restriction. However, this will only go from pi over 2 to negative pi over 2. Therefore, it's restricted in that sense. So it's more so the range is restricted. But if the range represents the domain of the regular function. So the domain of the trig function would be negative pi over 2 to pi over 2, meaning that the range of this restricted function would now be negative pi over 2 to pi over 2. So now you may be asking, why would we need to use inverse trig functions? Well, there's going to be instances in pre-calculus where you are asked to evaluate trig functions. In this case, we have arcsine of -1 of inverse trig functions. So, using the knowledge that we know that the domain of arcsine is negative pi over 2 to pi over 2. So, I drew a unit circle. I x'd out this side because none of the functions will ever need to go to this quadrant. So we're looking for -1/2 for sine. And we know that sine, if you remember from trig, or if you just learned this in pre-calc, sine is equal to the x value. And if we're looking for a negative sign, the y value, So if we're looking for a negative sign, we will be looking in this quadrant, considering that all the y values are negative. So if we look at negative pi over 6, we can see that the sine value is indeed -1/2. So therefore, the arcsine of -1/2 is equal to negative pi over 6. The next problem we have is arc cosine of -√2/2. So we know that cosine has a domain of 0 to pi. Therefore, we will be looking from 0 to pi. And we know that if the cosine value is negative, or the x value is negative, we'll be looking at this quadrant, considering all the x's will be negative, and this is nothing right here, so we'll be looking in this area. So, as you can see, at 3 pi over 4, there is a -√2/2 on the unit circle. Therefore, the arc cosine of -√2/2 is equal to 3 pi over 4. Easy, now right? We have arctangent, which is a little bit harder. So we have the arctangent of the square root of 3. Now, tangent is a little bit difficult because you just can't look at the graph. Tangent is actually equal to y divided by x, which is opposite divided by adjacent if you were looking at a right triangle. And we know that the range is all real numbers and the domain is negative pi to negative pi over 2 to pi over 2, more importantly. So if we look back at our unit circle, we know that if we're looking for a positive root 2, considering that one of these values are negative, we'd be looking in this quadrant. So let's test out some numbers to see if they work. So when you are dividing by a fraction, you can multiply by the reciprocal of a fraction in order to make it simpler, because divided by a fraction is a lot of work. So I started with pi over 6, and I did y times the reciprocal of x, which is 1/2 times 2 root 3. And you can't have square roots at the bottom, so I did a separate problem where I multiplied 2 root 3 times root 3 times root 3 in order to get rid of the square root. So now we have 2 root 3 over 3 times 1/2, which is equal to 2 root 3 over 6, and this will cancel out, leaving you with root 3 over 3, which isn't what we're looking for, but it's still good information. So now we move on to pi over 3, which is root 3 over 2 times the reciprocal 2 over 1 from 1/2. Now we have, when we multiply that, we have 2 root 3 over 1, over 2, sorry, 2 times 1 is 2. These cancel out, and you are left with root 3. So the arctangent of root 3 is pi. Now I will show you an evaluating compositional function problem using calculus. So we have the tangent of arc cosine of 2 over 3. Now, in order to make this using calculus, we need to draw a right triangle. See, simple right triangle. Here's your right angle, and here's your angle, which I will use as theta. So we know that cosine, if you remember SOHCAHTOA, cosine is equal to adjacent over hypotenuse, meaning that the adjacent side and the hypotenuse would equal these values. So the adjacent would be 2, and the hypotenuse would be 3 in this instance. So what we were trying to figure out is this missing side. And for that, we can use the old reliable Pythagorean theorem. So we have 2 squared plus b squared is equal to 3 squared. 4 plus b squared is equal to 9. And now we have b squared is equal to 5. So in order to get rid of the square root, we have to take the square root of each side to eliminate these. So we have b is equal to root 5. So now we have the whole triangle solved. And you may be asking, what did we do that for? But that was in order to find a tangent. So now, since we know what the cosine is and we got this value, we can find the tangent. If you remember tangent from SOHCAHTOA, tangent is equal to opposite over adjacent. Therefore, we find the opposite side of the triangle, which is root 5, and the adjacent side, which is 2, x over y, if you remember from the last problems. Therefore, the tangent of arc cosine of 2 over 3 is equal to root 5 over 2. The next problem we have is the cosine of arc sine of negative 3 over 5. And what really tricks me out with these problems is how to draw the triangle. So you know cosine can either have a positive or a negative x value. So you can either draw your triangle like this or like this. And sine either has a positive or negative value. So you can draw your triangle either like this or like this. So there's really 4 different options for the triangle here, and I'm always confused of which one to use. But I don't want you to be. So considering the fact that this is a negative sign problem, you know that it would more so be this triangle, because if you reference a coordinate plane, all the negative y values would be in this lower quadrant. Therefore, you would use a triangle looking like this. So I'm actually going to draw my triangle like this. Or actually, no, I'm going to draw it like this. So we have the arc sine of negative 3 over 5. I'm going to draw my angle here, my right triangle here. So we know that sine is equal to opposite over hypotenuse from SOHCAHTOA. So the opposite of theta would be negative 3, and the hypotenuse would be 5. And similar to the last problem, we can do Pythagorean theorem. We can do Pythagorean theorem now. So we have 3 squared plus b squared is equal to 5 squared. So we have 9 plus b squared is equal to 25. And now we have b squared is equal to 16. In order to get rid of this exponent, we have to take the square root, which causes them to cancel out, and b is equal to 4. Therefore, 4 will be the value of this missing side. And now we want to find the cosine, which is adjacent over hypotenuse. So, the cosine of arc sine of negative 3 over 5 would equal to adjacent, which is 4, over hypotenuse, which is 5.
That is all we have for today, and please tune in for the next video.